the Bootstrap method, and we're going to talk also about confidence intervals. Okay, the Bootstrap method is a more general procedure that can be used to understand the distribution of any sample statistic. And it has to be a statistic because we need to calculate it from data. Okay, so it doesn't always have to be population means. It can be standard deviations. It can be medians. It can be other statistics as well. Let's consider this scenario in which your friend is an assistant professor and they're interviewing for jobs and they got a job offer. They've been told that the salary offer will be competitive and about average, and that the discipline is not going to affect salary because at this university, everyone gets paid the same salary. Okay, so this data set is from the university your friend's considering employment, and we want to calculate a 95% confidence interval for what a reasonable salary might be. So we're only going to consider salaries of individuals who are assistant professors. So for example, this individual. So we're going to subset the data, and we do that here. Okay, so we select only assistant professors and we select only the salary data. Okay, so here's a little snippet. There's a lot more data than this. Okay, and we're going to apply what's called the Bootstrap method. So the Bootstrap method is called a resampling method. And the idea here is to create what's called many bootstrap samples, or boots, by randomly sampling with replacement the original data. And by resampling, allowing a data point, more than one data point, to be included in the data set more than once, we're introducing variability to our statistics, which is the key to understanding the distribution. So almost every bootstrap that we calculate is going to be slightly different in its value because of this resampling procedure. Okay, and this resampling with replacement, as I mentioned, it's what introduces the variability. So a data point could be included more than once into your estimate. Okay, the sample size of your resampled data has to be the same as your original data. Okay, so with this resampled data, you calculate your statistic, and that's one bootstrap. You repeat this procedure many times, producing your bootstrap samples, so many bootstraps, and you repeat that process of generating the samples, and what that does is it estimates the distribution of that statistic. Okay, so here's the algorithm for that, and this is the implementation in Python of this bootstrap samples. Okay, so we just feed in our data. The default number of bootstraps that we calculate is 1,000 here. It can be any number you want though. And what we do is 1,000 times we randomly sample our data, allowing replacement. Now, the size of our Bootstrap sample data set is the same as the original data. So we're randomly allowing some of the data to be duplicated and some of the data to be excluded, and we do this many times to try and understand the variability and the estimates of these values. So this is the Bootstrap samples, and we apply it here. So this is one Bootstrap sample. By using this for loop, we've calculated the number of the n iterations is how many times we calculate a Bootstrap sample, and then we return all the data which is calculated from this Bootstrap here. Okay. We're going to apply this process to the Bootstrap sample data set with this line of code here. we need to run the code. So let's run all. This will take a moment. Okay, so it ran, and when it runs, it just returns a data set of Bootstrap samples to estimate what your average for that statistic, which is the mean, would be. You calculate the average. And so here, your estimated mean is just given here, and it's this 80,822 dollars. That's your estimated salary. Now, if I want to calculate a confidence interval, I can just calculate it with percentiles, just from the data, not using a distribution for percentiles. So here I want 2.5% of the data to be less than this value and 2.5 to be greater. And we see that a 95% confidence interval is between $78,900 about and $82,796. Okay. And to understand the distribution of the statistic, we can make a little histogram. The little histogram is given here. And we can see that here the black dotted curve represents the average. That's right about where the peak is here. And the lower estimate being the 78,900 being down here. The upper estimate of 82,796 being over here. And that this shape resembles a normal distribution, not surprisingly. Okay, something that resembles a normal distribution. Now, we can recall there's another way to calculate a confidence interval from data, and that's with the t-distribution using this formula. If we were to use this formula, we'd just run this line of code, and we'd get $7,882 as the low estimate, and this 82,769, so $82,769 as the high for the t-distribution. Let's see how that compares. $7,800 and $900 as compared to $7,800 and $782. So very similar, slightly different process. And now the upper bound is 82,796. Here is 82,769. Very, very similar. Okay. So these are two different processes to calculate a confidence interval, but the Bootstrap does more than just calculate confidence intervals. It calculates or estimates the distribution here. Okay, and it's as shown by this histogram. So it's a very, very powerful method. It goes beyond just calculating confidence intervals. One thing I'd like to do is I'd like to rerun this function, which will, there's no seed set here. So every time I run this, it's going to give me a random outcome with this command here by selecting my data randomly. Okay, so if I run this again, let's see what happens. So notice my estimates change just slightly, right? But they're very similar, and that's a good thing. The reason why they're different is because of randomness, okay? But the amount from which they vary at each time I run it isn't that much, um, because the process approximates it well. Okay.